Today is the second day after the Masters, and, while the world is still buzzing about the green jackets and those iconic fairways, and obviously the roars echoing through the pines, we are turning our attention to the unsung, brilliantly white heroes of the tournament.
Right, the bunkers,
Right.
which honestly are completely misunderstood by almost everyone watching the broadcast.
Completely misunderstood. And as a head greenkeeper myself, I watch the coverage and I just shake my head because I know that what the greatest golfers in the world are hitting out of isn't even dirt. It's essentially like crushed up, rejected smartphone screens.
Yeah, I mean, it sounds totally absurd when you frame it that way, but chemically speaking, you are spot on. It's an industrial byproduct.
And that reality is the entire mission of our deep dive today. We've pulled together a massive stack of sources, agronomy reports, geological analyses, course architecture interviews to uncover the hidden science and, frankly, the mind-blowing engineering of Augusta National's pristine white bunkers.
It's a level of engineering that most local courses couldn't even dream of.
Exactly. So whether you are a scratch golfer trying to figure out how the pros get so much spin out of the sand, or you, the listener, are just someone fascinated by behind-the-scenes geology and engineering, this deep dive is going to completely change how you view a sand trap.
We really should establish the core premise right out of the gate, though, because from an agronomy standpoint, and speaking from the Augusta greenkeeping perspective, that brilliant white material in those bunkers isn't actually sand. Not in the traditional sense, anyway.
Right. It's not beach sand.
No, not at all. Its flawless appearance on television is the result of cutting-edge geology and highly advanced subterranean engineering. It's not just nature taking its course. So before we can even understand how these specific hazards play, we have to look at what normal golf course sand actually is.
Yeah, let's start there because, normal sand is what you find at the beach or what I have in the traps at my municipal course. It's that beige, gritty, somewhat inconsistent stuff.
Geologically speaking, standard golf course sand is sedimentary. It's silica that has been weathered, tumbled, and transported by rivers, wind, and oceans over thousands of years.
And because it's moving through water all that time, the friction acts like sandpaper. It rounds off all the sharp edges of the grains.
Exactly. You get these very smooth, rounded grains. But crucially, while it's sitting in those riverbeds or oceans, the silica acts like a giant sponge for impurities. It picks up iron oxides, feldspar, clay, all sorts of minerals.
Which is why it's brown.
Right. The oxidation of those specific minerals is exactly what gives standard sand its tan or beige color.
But when you look at Augusta's bunkers, they look like bowls of perfectly white powdered sugar. There is not a single hint of brown or beige in them.
That pristine aesthetic is due to a material that the industrial sector officially calls SP55.
SP55 sounds like a chemical formula.
It pretty much is. It is a granulated igneous quartz, and it's sourced exclusively from one very specific, highly protected place on Earth, the Spruce Pine Mineral District up in North Carolina. It doesn't come from a beach. It was literally forged inside a mountain.
So wait, how does quartz get forged in a mountain in a way that keeps it so brilliantly white? Like, why doesn't it have those iron oxides?
Well, it goes back about 380 million years to a geological event called the Akkadian orogeny.
The Akkadian orogeny. Okay.
Yeah, this is massive tectonic collision where the African and North American continental plates just slammed into each other. That collision generated intense friction, heat, and pressure miles below the Earth's surface.
Wow.
But the defining characteristic of this specific tectonic event was that it was incredibly dry. There was virtually no water present deep in the crust when this quartz crystallized.
Oh, I see. So without water, there's no transport system for the iron oxide or the clay to get into the silica.
You got it. It cooled and crystallized in total isolation. And that resulted in a chemical purity of over 99.9% silicon dioxide. It is staggeringly pure.
That is wild.
It is. But here's the crazy part. The primary market for spruce pine quartz has absolutely nothing to do with golf. It is the lifeblood of the global semiconductor industry.
Right, because I was looking at the industry specs in our sources, and the tech sector requires a purity standard known as 5 nines, meaning 99.999% pure.
Exactly. They need that ultra-pure quartz to manufacture the crucibles that melt down silicon for microchips, fiber optics, and solar panels.
So where does the golf course come in?
Well, the SP55 material used in the bunkers is essentially the stuff that just barely misses that 5 nines mark. It might have a microscopic fraction of a percent too much aluminum or titanium to be used in a supercomputer.
That is just incredible. So instead of being melted down to build the processor inside your phone, it gets shipped to Georgia to become a golf hazard. It's literally the tech industry's reject pile.
That's exactly what it is.
But wait, Augusta opened back in the 1930s. That was way before the silicon chip boom or, fiber optics were even a thing. How did a highly specialized industrial tech quartz find its way onto a golf course in the first place?
That's a great question. For decades, Augusta actually did use local Georgia sand. But you have to look at the course's co-founder, Clifford Roberts.
He was known for being incredibly demanding.
Oh, famously a perfectionist. And by the early 1970s, he was deeply frustrated with that native sand. It was coarse, it drained poorly, and honestly, the beige color looked really dull on the new color television broadcasts.
He wanted a complete visual overhaul for TV.
Right, and he actually found the solution completely by accident. Roberts had a seasonal home in North Carolina near that Spruce Pine District. And during a visit to the Linville Golf Club, he noticed they were using this striking white quartz in their trap.
Just a local course using the local rock?
Yeah, but Roberts was captivated by the sheer visual contrast, the way the chalk white material popped against the emerald green turf. So he met with Linville's manager, Claude Green, tested how a club moved through the quartz, and immediately ordered 13 railway boxcars of it to be delivered for the 1975 Masters.
Which, reading through these architecture interviews, did not go smoothly at all. The first massive delivery in the 70s was an unmitigated disaster.
It's a total nightmare.
Because they didn't just dump it in pristine containers, right? To move that sheer volume of rock, the railway used old boxcars that had previously been hauling coal.
Yeah, a catastrophic logistical oversight. You have to remember, because this quartz is mined and milled, it's highly fractured. The grains aren't smooth, they are covered in microscopic jagged crevices.
Like tiny little claws.
Right. So during transit, the residual black coal dust inside those boxcars shook loose and embedded itself directly into the microscopic fractures of the white quartz. When the train finally arrived in Georgia, the brilliant white SP-55 had turned into this dull, filthy gray gravel.
Oh, man. And you can't just hose that off?
No, it was baked into the fractures. Industry veterans still joke about the legendary mulligan Roberts had to take. I mean, he refused to let a single grain of that gray mixture onto his golf course.
I can only imagine the phone calls he made that day.
Oh, he ordered the entire batch discarded. He paid double and demanded a second delivery using completely sterilized, dedicated boxcars.
And the second batch was the charm.
Yep, it arrived perfectly white, and SP-55 has been the standard ever since.
But I'm thinking about the physics of that purity, though. We're talking about a mineral that is over 99.9% pure silicon dioxide, heavily fractured, with all these sharp facets. It doesn't just look white. It must reflect sunlight like a literal mirror.
It does.
So doesn't the glare on a sunny Georgia afternoon absolutely blind a player standing over the ball?
It's funny you ask that because Tiger Woods has actually made jokes in press conferences about needing his sunglasses just to walk into those bunkers. The glare is exceptionally intense when the quartz is freshly poured because those milled edges are razor sharp.
They act like millions of tiny prisms.
Exactly, refracting the sunlight.
Yeah.
But the agronomy team understands the weathering process. Over a year or two of exposure to rain, wind, and constant raking, the absolute sharpest microscopic edges soften just enough.
Okay, so it dulls down a bit.
Right. It doesn't lose its angular shape, but it dulls the reflective glare just enough. So you get that television-friendly visual contrast without physically blinding the athletes.
Well, let's shift from the visual to the physical side of things, because as a greenkeeper, I know it looks phenomenal on a broadcast, but a bunker is ultimately a hazard. Golf is about performance.
Absolutely.
You mentioned the sharp edges, which means this crushed igneous rock has to play drastically differently than the smooth beach sand you'd find at a typical course.
It radically alters the physics of the golf shot, and it all comes down to the geotechnical properties of the SP-55. We noted earlier that normal sedimentary sand grains are round. They essentially act like microscopic ball bearings.
Right. So when a heavy object, like a golf ball, dropping from a 100-foot apex crashes into round sand, the grains just naturally roll over each other and displace outwards.
Exactly. They make room for the object.
I like to use the bucket of marbles analogy for this. If I have a bucket filled with perfectly round, identical glass marbles, and I punch my fist straight down into that bucket, my hand plunges right to the bottom.
Because the marbles instantly roll out of the way.
Right. That's normal sand. And that totally explains the dreaded fried egg or plugged lie, where the golf ball buries halfway down into the trap.
That is a phenomenal way to visualize it.
Yeah.
Take that same bucket, empty it, and fill it with broken glass shards of entirely different sizes, all with jagged, angular edges.
If you push your fist into that,
My hand stops immediately.
right,
Because the jagged edges interlock and jam together under the pressure, blocking my hand from sinking.
that interlocking mechanism is exactly what engineers measure as a penetrometer value. A penetrometer is just a diagnostic tool we drop or push into the soil to measure its resistance to downward force. And I'm guessing SP55 has a massive value.
An exceptionally high penetrometer value. When the golf ball impacts the surface, those angular grains instantly lock together into a rigid matrix. The ball simply cannot penetrate the surface. It almost always sits perfectly up on top of the sand, which virtually eliminates the plugged lie.
Which is why Zach Johnson, the 2007 Masters champion, famously described Augusta's bunkers as having a soft top with a firm base.
That's a perfect description. The soft top comes from the groundskeepers lightly raking the very surface. But that firm base dictates the entire technique of the pro's swing.
How so?
Because the quartz locks together into that dense matrix, it is an incredibly heavy medium to swing a steel golf club through. The wedge digs in for a fraction of a second, but then it meets the immense resistance of that locked quartz. The sheer density deadens the impact energy.
So a player can't just casually splash the ball out like they would at their local club. They'd just chunk it.
Exactly. They have to be incredibly aggressive. To get the ball out, especially considering they have to clear the massive, steep walls of Augusta's bunkers, players must swing significantly harder.
And that affects the spin, right?
Massively. The ball comes out with a slower exit velocity and far less spin than it would from normal sand. It demands total commitment and a very specific touch. But what the pros actually love about it is that, while it's difficult, it is mathematically consistent.
Because of that high penetrometer value.
Right. It means the quartz reacts the exact same way every single time.
Well, talking about the mechanics of those steep walls, what the agronomy reports refer to as flashed bunker faces brings me to the biggest mystery I found in this entire stack of research.
Well, the washouts.
Yes. Flash faces mean the sand is pushed high up the vertical slopes of the bunker facing the golfer. If the angular sand locks together so well, how does it stay glued to a vertical wall during those torrential 40-minute Georgia thunderstorms?
It's the ultimate greenkeeping challenge.
Right, because anyone who plays a normal golf course knows that after heavy rain, the sand on the slopes washes straight down into a muddy puddle at the base of the trap.
And this is where we uncover the true secret of Augusta's bunkers. The flawless aesthetic isn't just the SP55 quartz. It is the staggering subterranean engineering hiding inches beneath the surface. Augusta National has long been the industry pioneer in what we call moisture management.
So what exactly is hiding under all that white quartz?
Back in the 1980s, Augusta's superintendent, Billy Fuller, recognized that washouts were constantly ruining the architecture of the course. So he invented a drainage infrastructure that revolutionized the sport. It became known industry-wide as the Billy Bunker.
Okay, I've heard of that. How did the original version work?
He basically excavated the traps and laid a network of herringbone drainage pipes at the base. Over those pipes, he layered 2 inches of local pea gravel, and then he capped the gravel with a synthetic fabric geotextile liner. The white quartz went right on top of the fabric.
Okay, I see the logic there. The water filters through the quartz, passes through the fabric liner, and rushes into the gravel and out the pipes. Meanwhile, the fabric prevents the native red Georgia clay from rising up and turning the pristine white quartz into brown mud.
The theory was completely sound, but the practical application was flawed. As you know, a golf course is a dynamic environment. Maintenance crews are out there constantly using metal rakes, and players regularly take massive divots with heavy sand wedges.
Oh, I see where this is going. They were ripping the fabric.
Constantly. Those tools would frequently snag the fabric, sitting just a few inches below the sand, tearing holes in the liner.
And once it's compromised, it's game over.
Exactly. Once torn, the gravel and the red clay would instantly mix with the expensive quartz, which ruined the drainage and completely destroyed the white aesthetic.
So how does a course with virtually unlimited resources solve a torn fabric problem?
By completely eliminating the fabric through modern chemical engineering.
Okay, now we're talking.
The current iteration is called the Better Billy Bunker system. After they lay down that 2-inch layer of pea gravel over the pipes, they don't use a liner at all. Instead, they spray a highly specialized liquid polymer known as ST410 directly over the rocks.
Wait, hold on. If you spray a liquid plastic over rocks, wouldn't it just cure into a solid, impenetrable sheet of concrete?
That's what you would think.
Because that defeats the entire purpose of having a drainage pipe underneath it. The water would just bounce right off.
But the chemistry of ST410 is specifically engineered to avoid that. It does not form a solid sheet. The liquid polymer only coats the individual pieces of gravel.
Oh, fascinating.
Yeah, so when the stones settle against each other, the polymer cures and acts as an adhesive, strictly at the contact points where the stones touch. It binds the entire gravel layer into a locked matrix, but it leaves the microscopic empty voids between the stones completely open.
That is absolutely brilliant. So it creates a solid floor that won't tear but remains totally porous for the water. But wait, what happens if a pro misjudges their swing and digs 4 inches deep? Are they going to shatter their wrists hitting a layer of polymer-glued rock?
The engineers actually accounted for the kinetic energy of a golf swing. The ST410 polymer retains a slight flexibility after it cures. So, in the highly unlikely event a club blade does strike the base, it's designed to safely repel the club rather than completely halting it and jarring the player's wrists.
That's good to know.
But more importantly, our agronomy team prevents this from ever happening in the first place. We use specialized depth-checking probes every single day to ensure the SP55 quartz is always deep enough that a club will never ever interact with the base layer.
Insane attention to detail. So if the voids in the gravel are left open, how fast does the system actually drain?
At a rate of over 1,500 inches per hour.
1,500 inches. That isn't a rainstorm. That is the equivalent of a fire hose.
And that extreme flow rate is the exact reason those flashed faces never wash out. When a thunderstorm hits, the water literally never has time to pool on the surface. Because the drainage system below is pulling water away at 1,500 inches an hour, the rain is sucked vertically, straight down through the locking quartz and into the polymer-bound gravel.
Which completely eliminates horizontal surface flow.
Exactly. Water moving horizontally down the face of a slope is what drags sand with it. When the water moves purely vertically, the sand stays exactly where it was placed.
So no washouts.
No washouts, and no maintenance crews out there for hours with shovels pushing sand back up the walls.
The level of control is just breathtaking. I mean, we are looking at a material forged 380 million years ago, mined and rejected by the semiconductor industry, shipped in sterilized boxcars, and then carefully layered over a chemically bound, highly porous subterranean drainage network.
It really is a marvel of modern environmental engineering.
But I imagine this relentless, highly televised pursuit of perfection has created some issues for the rest of the industry, right? I've seen it referred to as Augusta syndrome.
Oh, Augusta syndrome is very real. It's an unintended psychological effect on the sport.
Is that the delusion where an amateur watches the broadcast and suddenly believes they have the skill to hit a spinning flop shot off a downhill lie?
Well, not quite, though that is definitely a real phenomenon. No, Augusta syndrome refers to the incredibly warped expectations of the average golfer regarding course conditions.
Oh, the complaints.
Exactly. Because Augusta's bunkers look so flawless and drain so perfectly on television, amateur players return to their local public courses and aggressively demand to know why their bunkers are brown or why they're ball plugged or why there are puddles after a storm.
Right. They want their local, $40 a round municipal course to look exactly like the Masters.
And what they completely fail to realize is the staggering financial and infrastructural reality required to achieve that look. I mean, the SP55 quartz alone costs upwards of $100 to $180 per ton.
And that's not even including the specialized transport required to keep it clean.
Not at all. Then you have to factor in excavating every single trap, laying the herringbone pipes, buying the pea gravel, spraying the ST410 polymer, and paying a massive crew to conduct daily depth and moisture checks.
Which is just wildly out of reach for almost everyone.
It is a level of hypercuration that is financially impossible for 99% of golf courses on the planet. Augusta National doesn't just maintain their course, they aggressively engineer their environment to entirely eliminate the concept of variability.
And that actually leads me to a final thought I want to leave you, the listener, with to mull over. Because we've just spent this entire deep dive exploring how modern agronomy, millions of dollars, and subterranean chemical engineering have completely eliminated the unpredictability of these bunkers. The drainage is guaranteed, the ball sits up perfectly every single time, the lie is mathematically consistent. So if a hazard on a golf course is engineered to be entirely predictable and flawless, does it actually cease to be a true hazard?
There's the big question.
Right. Or has it simply evolved into another perfectly tailored hitting surface designed more for the aesthetic demands of the television cameras than the actual punishment of the player? It's definitely something to think about the next time you watch a pro blast out of that brilliant white quartz.
Well said.
If you enjoyed this content, please subscribe to our channels.